All right. Good morning, everyone. Can you guys all hear me and see my screen? Just want to make sure I don't start without everyone having everything. Great. Thank you. Um, Before we get started, I just want to see if anyone had any questions about what we covered or where we are in the class. Just to remind you guys, we finished covering which module 9. And we're working on module 10 right now. We're going to wrap it up here in a few minutes with section 4.10, and then we're going to get started on 5.1, talking about decimals, and module 11. If you guys remember, there's 13 modules in the class, so we're getting close to the end, which I know a lot of you are probably relieved, especially with the new environment we're in. So I appreciate you guys. I know it's a lot of work, and I know it's hard to transition to home. So I do see that you guys are trying, and I think that's awesome. So that's, like I said before, all we can do is our best. So does anybody have any questions before we get finished with wrapping up section 4.10 here? Okay. So one of the things that we were talking about, or most of what we were talking about last week, was applying like word problems with fractions. So we left off with doing the averages. That was the big thing we talked about with this problem. So make sure you understand how to find the average. The idea is that you add up all the values and divide by the total number of values. Remember this example right here, this track and field long jump. We had 3 jumps, 6 2/5, 7 1/10, and 5. So we added those 3 numbers together, and then we divided by 3 to find the average. So make sure you understand how to find the average, and then let me know if you have any questions about that. But the idea last section in part F was to use the order of operations with fractions. So now we're going to solve problems that involve pre-algebra with triangles, surface area, volume, and more. So this is looking at shapes where we talk about surface area. Remember, surface area is like this when you have a 2-dimensional shape and you're finding this shaded area. So we will now solve application problems that involve formulas and equations. Here are some new geometric formulas for perimeter and area that we will use. Remember, perimeter is the total lengths around the edges. So it'd be A plus B plus C. And then the area is that shaded region. And here's the formula. So perimeter equals A plus B plus C. Area equals 1/2 the base, which is B in this case, times the height, which is H right here. For a parallelogram is anytime 2 of the sides are parallel to one another. So it could be a square, rectangle, but this is also a parallelogram. Anyway, the perimeter is very similar, where you have 2 times A plus 2 times B, which is again just adding up all the sides. The area is the shaded region. It's the area times, area equals base times the height. And here's a trapezoid where the perimeter equals the base here, that big side on the bottom, plus A plus B plus C. So it's all of them around. But the reason they have that big B is to it's the base. So the area of a trapezoid is 1/2 the height times the base plus that little b. So big B plus little b. The reason for that is, this is a side note, so if you're confused, don't even worry about this, but it's 2 triangles with a square or rectangle in the middle. That's why that works like that. All right. Some of the applications will involve calculating the volume or surface area of a rectangular solid. When they say rectangular solid, think like shoebox. It's a basically like a cube or rectangular solid box. Volume is a measure of space or capacity. Volume is measured in cubic units, such as cubic feet and cubic meters. For rectangular solids, volume is calculated by multiplying the measurements of the 3 sides of the solid. Surface area is the total area of the surface of the 3-dimensional object. It is measured in square units, such as square feet or square meters. For rectangular solids, surface area is the sum of the areas of the individual sides. So let's just look at some pictures. I think that'll help. So here on the left, we have the cube. Here on the right, we have a rectangular solid. So this is kind of more when you think of a shoebox. It's like a little gift box. Here, the volume is S. So again, when it's a cube, all the sides are the same length, right? You have 3 different lengths. So you have S times S times S. That's going to be your volume. The surface area, remember, you have 6 sides to a cube. You have 1, 2, 3, 4, and in the back 5, and in the bottom 6. So when there's 6 sides, what it's saying is 6 times the area of 1. So in this case, the area of 1 is going to be s times s, which is s squared. And you multiply that by 6 for all the sides. For a rectangular solid, so this is when they're not all equal, you have the length, width, and height of this box or this rectangular solid. So the volume equals length times width times height. So it's L times W times H. And the surface area equals 2 times L times W. And that's because on the bottom of the box, that's one side is the same side as the top of the box. Then you have 2 times H times W, which is here on the front and then on the back. And remember, there's 2 sides that are always equal to each other. Then we have 2 times H times W, which is going to be this side over here plus this side over here. So we have 2 different problem types. We have use a formula. So examples of that are a triangular piece of cloth has a base of 2/3 yard and an area of 5/6 yards squared. What is the height? So in this case, you're using formulas that are already known, like these volume and surface area formulas. Creating an equation from words is where, let's see an example. You are framing 6 pictures. Each picture is 4 and 1/8 inches wide and 6 and 1/4 inches long. How much total framing material will you need to frame the pictures? So in this case, you have to create an equation. Amount of framing equals 6 times this. Whereas this one, you're using a formula, area equals this, where you're given the numbers. Important notes, a parallelogram is a 4-sided figure in which opposite sides are parallel. Notice that the sides do not necessarily meet at right angles. A trapezoid is a 4-sided figure in which at least one pair of opposite sides are parallel. A rectangular solid is a 3-dimensional object with 6 rectangular faces. Always ask yourself whether the answer makes sense for the situation described in the problem. And I really wanted to touch on that. I know I said this to you guys 100 times, and I'll probably say it several more before the end of the semester. It's really important that you do that. When I was going through the test results, I think there was I can't remember if it was a banner or whatever it was, you had a rectangle and you were given the area and you had to come up with one of the lengths of the sides. I noticed some people got a bigger length than the area or the perimeter, and that's not something you should see. So if you get that answer, you know you did something wrong and you should probably go back and check your answer. So make sure you're always just double checking your answer and make sure they make sense. All right, so let's go down to an example. So we're on page 138 and we have your turn 5. So here we're given the perimeter of a rectangular garden. This is kind of similar to what I was just talking about. So find the perimeter of a rectangular garden where it's 6 2/5 meters long. So let's go ahead and draw our little rectangle. So we have 6 2/5 meter long and 4 1/4 meters wide. So we're also given that the perimeter equals 2 times L plus 2 times W. Again, that's just adding up all the sides. So 1, 2, 3, 4 sides. If your answer is an improper fraction, rewrite as an integer or mixed number. So we're trying to figure out the perimeter. And it's similar to saying, how much total fencing do you need to enclose a rectangular garden? It's the same idea. How much wood would you need to frame out this garden? It's just that instead of using words, this is more using just straight the formula. So I just make sure you guys understand the difference there too. So we're given the length and we're given the width, right? And all we need to do is plug those numbers in. So the perimeter equals 2 times 6 2/5 plus 4, 2 times 4 1/4. Now, you can leave this as mixed numbers, but honestly, when you start trying, you guys can't see that. Once you start trying to multiply with mixed numbers, it's really not always that easy. So what we're going to do is first we're going to convert these to improper fractions, right? We have our little multiply and add. So let's write that out first. So now we have 2. 5 times 6 is 30, plus 2 is 32, all over 5, plus 2 times, here we have 4 times 4 gives us 16, plus 1 is 17 over 4. So let's go ahead. Let's write that on the next page. I might have to go back and forth, so please forgive me. We have 32 over 5 plus 2 times 17 over 4. All right, so when we multiply these, remember, 2 is the same thing as 2 over 1. So if you have a hard time in your like wrapping your mind around the numerator and denominator, make sure you write it like that. So we're just going to multiply across. So 2 times 32 gives us 64 over 5 plus, again, we're just going to multiply across, right? So that means 2 times 17, which is 34 over 4. Can we just add those numbers? Can we add those numbers like they are? Well, we can, but there's something we need to do first, right? We need to have the least common denominator. So the easiest way probably to do this one, let's go ahead and do the division method. So right, we have our 2, 3, 5, 7. So let's start with 2. So 4 divided by 2 is 2. We cannot divide 5 by 2. We still have a 2. So 2 divided by 2 is 1. So now we're divided by 5. And we get 1 and 1. So our lowest common denominator equals 2 times 2 times 5, which equals 20, right? So in order to make this fraction have a denominator of 20, I need to multiply by 4 on the bottom and then on the top. And same on this side, I need to do 5 on the top and the bottom. Okay. Let's go ahead and erase this so we've got, make sure we've got room to work. All right. So that means we have 4 times 64, which gives us 256. So here we have 256 over 20 plus 34 times 5, which gives me 170 over 20. So when we add, remember, we add the numerators, but then we keep the denominator the same. So we're going to add 250. This is the same thing as 256 plus 170 all over 20. So 256 plus 170 gives us 426 over 20. And I'm not done there, right? Because I still need to convert this to a mixed number. But before we even convert it to a mixed number, I know that these numbers are both even. So I know I can at least pull a 2 out, right? I can divide top and bottom by 2. So that's going to give me 213 over 10. Now, I don't think there's anything else there to simplify, but I still need to convert it to a mixed number. So we have 213 over 10. So we need to divide that, right? 213. So 10 goes into 21 2 times, right? We have 1 left and then a 13. So we have 1 left, 2, 10, I mean, gives us a 3. So this gives us 21 remainder 3. So that means that we have now 21 and 3/10. So that means that our whole perimeter should be about 21 and 3/10. And let's look at this. We have 6 and 4 and 6 and 4. So if we were just to look at the whole number parts, we would have about 20. So it makes a lot of sense because look, we have 6 plus 4 would give us 10, plus 6 would give us 16, plus another 4 would give us 20. So if we were just to look at those whole number parts and get 20, it's not unrealistic that 21 and 3/10 would be our total answer if we include those fraction parts. So that answer is in the realm of reality. It makes sense. So that's probably the answer. So we're good to go. Does everybody see that? I just estimated it quickly by looking at the whole number portion. Okay. Any questions about that one? Okay. All right, let's go to the next example. Down here on page 4, we have height of a triangular piece of cloth, which is actually a little fitting right now with everybody wearing bandanas and stuff. You are making a small quilt using triangular pieces of cloth. Each triangular piece has a base of length 2.5 inches. So let's go ahead and draw our triangle over here for our worksheet. Oh, thank God you guys couldn't see what I just drew. That was terrible. Okay. 2.5 is the base. And then it says the base of length 2.5 inches in the area. So we know the total area equals 3 1/8 inch. Okay. So what is the height of each piece of cloth? So we're looking for the height. So we're given that area equals 1/2 the base times the height. Don't worry, I'm going to show you what I'm working on. I just want to make sure I got it all written down. So we're given that this area equals 1/2 the base times the height. That's just a triangular formula, the area for the area of the formula for the area of a triangle. And as you've seen in the quizzes and in the test, they will provide the formula in the problem that you need, which is also awesome because it gives you the best hint for what you need to solve. So we're trying to solve for this height, and we're given this one and this one. So we just need to plug in our numbers. So we're given 3 1/8 inch equals 1/2 times the base, which is 2 1/2 times the height, and we need to solve for that. So the first thing we need to do is convert these two numbers to I'll think of it in a second, to the improper fraction. So again, we're going to do our little circle here, our little arrow, multiply now. So we have 8 times 3 is 24 plus 1 gives us 25/8 equals 1/2 times, let's do our little area. We have 2 times 2 is 4 plus 1 is 5 times the height. Okay, so now we need to multiply these two. So we're going to get 25/8 equals, and we multiply across, right? 5/4 times h. Now, one of the things that we talked about on Tuesday was how to clear that fraction so that we can get h by itself. Does anybody remember how to do that? Nobody? Find the LCD. That's a good thought, but remember, that was when we need to clear the fractions from the whole problem. When we need to just clear that's a really good point, Shannon. So remember, when we have a longer one, let's say we were adding something here and had another fraction. I'm just going to show you an example. If we had something like that, that's when we'd find the LCD and multiply both sides of the equation by it. That's a really good point. In this case, all we need to do is multiply by the reciprocal of 5/4. You're right, Sarah, that's on the right. That's definitely the right idea, because we need to divide by 5/4, right? But remember, when we're saying divide by 5/4, that's the same thing as multiplying by the reciprocal. Remember, 5/4 divided by 5/4 is the same thing as 5/4 times 4/5. Remember, same dot flop. So that's exactly what we're doing. We're just going to multiply both sides by the reciprocal of 5/4 and multiply by 4/5. 4/5. Okay? So even though these are in different orders, remember, order doesn't matter with multiplication. So 5/4 times 4/5 cancels out. And then we need to multiply on this side. So we have, can we simplify it all before we multiply? Or let's go ahead and write it down here. We'll do 4 times 25/5 times 8 equals h. But what I see is I see that 4 and that 8 are both divisible by 4, right? So 4 divided by 4 is 1. 8 divided by 4 is 2. 5 divided by 5 is 1. And 25 divided by 5 is 5. Well, isn't this ironic, huh? So we end up with 5/4 equals h. Hold on. Let me check something really quick, because that doesn't work. Hold on. Oh, you know what? I just realized where my mistake was. I'm sorry, guys. I said this was a 4. That should have actually been a 2. Okay, so let me go back to this part. Let's rewrite this. Everything was right up to. So we have 4 times 25 over 5 times 8. But 4 divided by 4 is 1. 8 divided by 4 is 2. I am so sorry about that. 5 divided by 5 is 1. 25 divided by 5 is 5. So we end up with 5 over 2 equals 8. There we go. I'm sorry about that confusion, guys. All right, so that's how you would solve it. The main idea is when you're multiplying mixed numbers, you need to first convert them to an improper fraction, then do your multiplication, and then solve the algebraic equation just like we have in the last few sections. Okay, any questions about that one? Okay. All right. Okay, let's see. So that is it for 4.10. Just I gave these to you last time, but let's go ahead and I want to give you the section 4.10 practice problems again. So here again for 4.9 that we finished on Tuesday, we had 9, 15, 21, 27, 31, and 41. And then for 4.10, we had 11, 13, 15, 17, 19, 35, and 39. So that is it for module 10. We're done with module 10. So now we're going to start talking about module 11. And it's 2 sections just like module 10 was. So we're going to start with 5.1. I think you guys are going to like this better because it is decimals instead of fractions, which I know everybody likes me to do it on their calculator, the first thing, but also it's a little easier to manipulate the numbers. But the first thing we need to talk about is how to understand place value for a decimal number and write decimals in words. The reason this is so important is decimal places are very similar to the names for whole number parts. And this is something where I've seen people get confused. So it's really important that you guys understand this. So we've already seen that a fraction is a number that represents part of a whole. A decimal is another number format that expresses part of a whole. Decimal notation can be thought of as shorthand way of representing any fraction with a denominator of 10, 100, 1,000, etc. That is a denominator that is a whole number power of 10. So here's our place value chart. So we learned this back on the very first day of class. This is your whole number part of the number. So see our decimal points here. We have ones, tens, hundreds, thousands, 10,000s, etc. Now, to the right of the decimal point over here, that's our partial number, right? That's our decimal or the fraction area. That is the part that represents part of a whole, so part like less than 1. But it's really important. Notice it starts with ones here. Your first decimal place after the decimal is the tenths, and pay particular attention to how it's spelled. It's not tens, it's tenths. Then we have hundredths, thousandths, 10,000s, 100,000s. So starts here with the tenths, and then it follows a similar pattern that we had on the whole number part. It's just really important for you guys to pay attention to that because I have seen people mix up when it says tenths, they accidentally put it in the tens place, like on the whole number side. So just be real careful with that. So here we have examples so you guys can understand how to go between decimal, fraction, and words. So here's a decimal of 0.3. When we read that, we read it as 3/10 or 3 over 10. So anytime that you see a number in this spot, that is that number over 10, if it's just that. Then we have 0.07, which is also 7/100 or 7 over 100. And again, if you were to read this, it would be 7/100. 2.5 is 2 and 5/10. See, that's 5 and it's in the tenths place, 2 and 5/10. which is also 2 and 5 over 10. Here we have negative 6.049. Notice that here we go to the last place. This is tenths, hundredths, thousandths. And notice that thousand is our denominator. And thousandths is what we put here. And again, up here, our last decimal place was the hundredths. So you do it based on where the last number is after the decimal. So here we have negative 6 and 49 thousandths, or negative 6 and 49 thousandths, 49 over 1,000. So how to write the decimal in words. So if you're given the decimal and you need to write it in words, you write the whole number part in words, write and for the decimal, and then write the decimal part in words as though it were a whole number, and write the place value of the last digit in the decimal part, which is what I was just telling you. Important notes, the whole number part is the part to the left of the decimal. When there's no whole number part, do not write and for the decimal point. So in this example, it's just 0.9. So you just write 9/10. You wouldn't write and 9/10 because there's a decimal there. Sometimes decimal numbers are spoken as follows, 3.42. Try to get the habit of using and place value wording. So here we have 3 and 42 hundredths. If a number is negative, write negative in the wording. So here we have negative 7.2 or 7 and 2/10. So negative 7 and 2/10. If a number has no decimal part in it, it is written as a whole number. So here we wouldn't say 3 and 0/10, we would just say 3. All right, so let's go down and do some examples of our own. So here we have, let's write this. So to write that as a decimal, we would say 27 hundredths. Okay, if we were to write it as a fraction, it would be 27 over 100. Okay. Oops. All right, and then down here, part C, we have negative 167.9. So the way we would write that is negative, and remember we write that whole number part first, so 167, and then we write an and for the decimal, and this is 9. So you write whatever's there, and then that's the last digit place, tenths. So negative 167 and 9/10. Does that make sense to you guys? Yeah, okay. So make sure, we'll do one more. I just want to make sure it's really clear, and we'll cover the different types of examples. So right here, we have this one, part B down below. We have 11.276. So we would write 11 for this part, and then write an and for the decimal. And then we write out the entire wording for this part. So it's 276. And then what place is that? That's tenths, hundredths, thousandths. Oops. Thousandths. So I do want to make it clear. It's not that you guys writing all this stuff is so important. It's real. The reason I personally find it so important to be able to write this out is because it shows that you understand what number we're actually looking at. We're not just looking at 11.276. We're looking at 11 and 276 thousandths. Okay, it's important that you understand what portion that is of that number. All right, so let's go down. Now we're going to talk about how to go from decimals to standard form. So this is kind of like going the other way. So now we will take decimals that are written in words and write them in standard form. The standard form of a decimal is a way to write a decimal using only digits. The two key things to watch for are the word and the stated place value. So again, we already did this whole number portion. We already did that in the very first day of class in the first module, but it's important now. So here we have 6/10. There's no and, so we know that we start with 0 point, right? There's no and it's, you just write a 6, and since it's the tenths place, you know you don't have to write anything after that or any zeros before it. Here we have 33 and 47 thousandths. So we know we have that 33 and means point, and then it's 47 thousandths. So remember, it goes to the last place. That thousandths lets you know that you have 3 decimal places. So since there's a thousandths, but you're only given 47, you know you have to put a 0 there to make sure that it goes all the way to the thousandths place. All right, so use the decimal point for and, write the whole number part to the left of the decimal point, write the decimal part to the right of the decimal point, making sure its last digit is in the place value indicated by the words. If this results in empty place value spaces, fill them with zeros. Important notes, when a number has no whole number part, you will see the word and. In that case, you will not see the word and. In that case, you put a 0 and a decimal point to the left of the number. For example, 5/10 is 0.5. Use zeros as fillers or placeholders to make sure the decimal part ends in the stated place value. All right, so we're on your turn on page 5. So we have 58 hundredths. Let me just scooch this down. So 58 hundredths. So I don't see an and, so I already know that I've got a 0 point in the beginning. 58 hundredths. Well, I know that that's the hundredths place, so I don't need any leading zeros. So let's go down here, let's see, to part C, and it says 206 and. So I know I'm going to start with 206.8 thousandths. So I know I need to go out to the third place, tenths, hundredths, thousandths. So that's 0, 0. Okay? Does that make sense? Okay. So here we're given, let me make this smaller so we can see this at the same time, and then I'll make it bigger again to show work. All right, so now we have on part B down here, we have negative 187 10,000ths. So since there's no and, that means that this is gonna be a negative point. That's how you do it when it's a point like that. You can do negative 0 point or negative point. I would just write negative point, but well, let's see, I wonder what, I'll double check on that, what MyLab requires you to do, but negative 187 10,000ths. So we're gonna have tenths, hundredths, thousandths, 10,000ths, and we only have 187. So we need to put a 0 there, okay? So let's go to part C, 207 and, so we know that we have 207 and with a point, 43 hundredths. So we know we're going to the second place, 43, we don't need any leading zeros. All right, pretty easy, right guys? Are you guys okay with that? All right, let's go back. Clear that. All right, so now we're going to write decimals as fractions or mixed numbers, and this is where it's actually good. This is where you can understand what fraction we're looking at and how the decimals correspond to one another. So here, to write a decimal in fraction or mixed number form, we use the decimal part as the numerator and the place value of the last digit as the denominator. Whole number parts remain as whole numbers. So look at this example. We have 0.27 equals 27 hundredths. And like we talked about earlier, that corresponds to 27 over 100. Here we have 8 and 9 tenths. So the whole number part stays as your whole number part, and then you just worry about the fraction part, which is 9 tenths. So we have 8 and 9 tenths. Here we have 4.067. That one's a little trickier because some people might just write 67 over 100. However, it's really important. You have 3 decimal places here. You need to have 3 zeros down here. So your whole number part is 4, just like here. Then your numerator is whatever's after that decimal. And then since we have 3 decimal places here, we have 3 zeros. So it's 67 thousandths. Remember, tenths, hundredths, thousandths. All right, so the process is to keep the whole number part to the left of the decimal points, create the fraction part. So the numerator equals the decimal part, that's the number to the right of the decimal point, and the denominator equals the place value of the digit to the farthest right position, and then simplify the fraction part. Important notes, The number to the left of the decimal is a whole number. I think we've said that a few times. The number to the right of the decimal point represents a fraction. The numerator is the number shown. The denominator is 10, 100, 1,000, etc. It's going to be a multiple of 10. Always simplify the fraction part. So here's the good example, and this is what we're going to need to do as we work through this section. Here we have 0.4 equals 4/10, but that's not simplified. That simplifies down to 2/5. That means that the decimal 0.4 actually equals 2/5. So that's important to note. Saying the decimal number in words first makes it easier to figure out the whole number part and fraction part. All right, so let's go down. We're on page 7. So write each decimal as a fraction or mixed number and be sure to completely simplify fractions. So here on part A, we've got 17.46. So we know we have our whole number part, right? Is to the left of the decimal. Now we have our fraction part. This is tenths, 100ths. So we're gonna have 46 over 100. Hundredths place, 2 decimal places and 2 zeros. Am I done at this point? No, very good, Shannon, because we have a number that we can reduce, right? Now we're gonna leave that whole number part alone because it says here to leave it as a mixed number. They do not want improper fractions. So we only have to simplify this part. So we know that both of these are divisible by 2, right? That's one start. So 46 divided by 2 is 23 over 50. I don't think that can be simplified any further. Let me double check. Nope, it cannot. So we know that this equals 17 and 23 over 50. So that means that this decimal equals that fraction. Okay. All right, let's go to the next one. All right, so here we have negative, here, let's do it like that, oops. Let me do that. Okay, so we have part B is negative 0, oops, so they did put 0 there. Negative 0.305. So make sure you do that when you're entering your numbers into MyLab. It looks like it's going to require that 0 in front. So if it's a negative, make sure you write negative 0 point. Okay. So negative 0.305. So to start that, we don't have any whole number part, but we do have a negative, and we have 305 over tenths, hundredths, thousandths, so 1,000. Again, to double check, we have 1, 2, 3, 1, 2, 3. Okay, and I know that can be reduced. I think a lot of like decimals are a lot easier, right? So we have 305 over 1,000. If we were to divide both by 5, we would get negative 61 over 200. And that's as reduced as it gets. And it's a proper fraction because it's less than 1, right? Because the negative, or the top is smaller than the bottom, so you're good to go. Any questions about how to do those? All right, let's do these two real quick. All right, so we have 0.5. So that corresponds to, there's nothing in the beginning, right? It's 0.5, sorry, 0.5. So there's no whole number part. So we have 5 over, this is the tenths place, right? 1 decimal, 1 0, but that's definitely not simplified, right? It's going to give us 1 over 2, 1/2, which is nice. We all know that 0.5 is 1/2, but this is how you can see how it gets there. And then the last one we're going to do is that one that's got several places, 75.008. So remember, we first write our whole number part, so we have 75, and then here we have 8. And then what number do I put on the bottom there? Check the decimal places again. There's 1, 2, 3 decimal places. Very good. It's the thousandths place because we have tenths, hundredths, thousandths. 1, 2, 3, 1, 2, 3. Now, that's not simplified, right? If we divide top and bottom by 8, we get 75 equals 1 over 100. Oops, excuse me. Goodness gracious. 125. So we have 75 and 120, 100 or 120 25ths. Excuse me. All right. Everybody feel pretty good about those? All right. So the next thing we're going to talk about is how to compare and order decimals. What's nice, remember with fractions, it was hard because we would have to find a common denominator and then compare their numerators. This is going to be a little easier than that. So here we can use several different methods to compare two decimals and decide which is larger. We can compare the decimals as fractions, graph the decimals on a number line and compare their positions, or line up decimals vertically and compare their place value digits. That last option is like what we did when we compared whole numbers. So that one's probably your easiest option, but let's make sure we understand how to do them all. So in this case, we have 0.4 is clearly less than 0.5. They're both in the 10th spot and the 4 is smaller than the 5. But the reason for that also is 4/10, this corresponds to 4/10 and this corresponds to 5/10, and that 4 is less than 5. Down here we have 1.8 is greater than 1.2 by looking at the number line. We know 1.2 is closer to 1 and 1.8 is closer to 2. Now, be careful, just like we learned with whole numbers, when we start looking at negative numbers, it's the opposite. The 1.8 part is bigger, but it's farther from 0, remember, in the negative direction. Here, 1.2 is bigger because it's closer to 0 on the negative side, right? It's farther to the right on the number line. So in this case, on this one though, we have 0.351 and 0.3279. What you do here is you line up the decimal and then write out the numbers and you start comparing left to right. The 3's are the same, and then we come here and the 5 is bigger than the 2, so that means that 3.51 is bigger than 0.3279. So here you can line up the decimal points, write the numbers vertically, compare place value digits working left to right, and at the first place value where the digits differ, for positive decimals, the decimal with the larger place value digit is the larger decimal. For negative decimals, compare as if they are positive, then reverse the direction. Try getting in the habit of using the line-up method shown in the process when comparing your decimals. You might want to use the fraction or number line method at first to help you better understand what's happening. I really do think that line-up method is the easiest if you don't see it right away. Be careful when comparing negative numbers. If a negative number is more left on the number line than the other negative number, the number that is more left is smaller. If a number does not have a decimal point can be inserted after the number along with the ending zeros if it's helpful. So let's say you see 2 and then there's 2.006 and you want to know which one's bigger. You can always add in leading zeros, or excuse me, trailing zeros. Some students find it helpful to add ending zeros when comparing decimals. For example, here we have 0.04 and 0.004, and add an ending 0 to 0.04 to compare. So you can just line them up. And we'll go through some examples that'll make that pretty clear. So let's go down. We're on page 9 on your turn. So let me go ahead and write these real quick. We have 2.05 and 2.04. So in this one, we would just line them up, 2.05. And if you see this without lining them up, that's okay too. So we compare here, they're the same. Here, this number is bigger, so that means that this number is greater than that one. Remember, you have the little comparison point to the smaller number. Okay? So now we have 16.001 and 16.01. So let's line them up and see which one's bigger. So we have 16.001, 16.01. And what they talked about with extra zeros is if you want to put another 0 there to compare, you can. You don't have to. But again, same. Oh, there's our difference. So we know that this one's bigger, right? All right, now let's look at C, and we have negative 3.72 and negative 3.73. So what they suggest, and I think it's a good suggestion, so it just depends on how you see this better. If you line them up, let's just pretend like they're positive in our brain. So we have 3.72 and 3.73. When they're negative, you just compare them as if they're positive. Here's our first difference. So this is bigger. It says reverse them. So we would say this is bigger, but since we're looking at the negative, we're going to say that this is bigger. And if you need to write them on the, oh, can't see it. Sorry about that, Joy. Thank you. Let me reiterate that. Okay. So on this one, we have, remember when we have the negative, what we do is we compare as if they're positive and then flip the sign. 3.73. So again, same, here's our difference. So we would say 3.73 is bigger, except now we are looking at the negative. So we would say that that negative 3.73 is smaller than negative 3.72. So if you have negatives, just compare as if they're positive and then flip it. All right. Now, one of the things it has us do is order from largest to smallest. So now you have to compare a couple with each other. So here we have, I'm just going to write it and then actually I could do this probably. Here we have 8.6, 8.1, and 8.39. So what we could do is you could compare all three of them together, 8.6, 8.1, 8.39. And if you want, you can put zeros there. You don't have to, but if it helps you compare, that's fine. So all the 8s are the same, but here they're all different. So this is the biggest, right? This is the second biggest, and then this is the third biggest, right? So that means that we would put these in order. We would say, oh, excuse me, I went from smallest. This is the smallest, next smallest, then the biggest. So we would say 8.1, 8.39, and then 8.6. That's the order from smallest to biggest. Okay. All right, let's do a couple more of these. We have, I'll move the screen in a minute to 25.901 and 25.9. Okay. All right, so let's line them up. We have 25.9 and oops. Helps if I write what I say, right? 25.9 and 25.901. So same. Oh, that one's bigger. So this is the bigger number. Also, here's a tip. If you see that these are exactly the same, but this has additional numbers over here, that means that number is going to be bigger. Okay. Now let's do one more ordering. Here we have, because this one's a little more difficult to see right off the bat. We have 0.003, 0.3, and 0.03. And it says order smallest to largest. So we can line them up. 0.300, 0.030. Well, we see right off the bat that this is the biggest, right? So that's going to be our last one because look, it's the only one that has anything there. Then in the next row, we see that this has something there, but there's all zeros here. We're not even looking at that one. So we know it's our second biggest, and that's our smallest. So we're going to order at 0.00, oops, 0.003, 0.03, and then 0.3. Okay, any questions about that, guys? All right. Let's go down to rounding decimals. Again, we already talked about this when we rounded whole numbers, but it's just to show you how to do it on the other side of the decimal point. So here we have rounding a number means changing it to a more convenient value. For example, 34.55783.214 rounded to the nearest hundredth is 34.56. This number is easier to add, subtract, multiply, or divide than the original number is. I just want to point out one really famous rounding is, I'm sure you guys have heard of pi, like that, but you always see it as 3.14. That's rounded because it actually goes on for in infinite numbers. So it's one of the most famous rounded numbers you'll ever see. So here's an example, round to the nearest tenth. We have 1.21. So what you do is you underline the tenths place where you want to round it, and you look to the number to the right. If it's less than 5, you round it down. So that would round down to 1.2. If it was 5 or higher, you would round it up to 1.3. And this little diagram just shows you if it's closer to 1.2 or closer to 1.3. Since 1.21 is very close to 1.2, that's why we round it down. Okay, so the process, underline the digit in the rounding place, look at the digit to the right of the rounding place. If it's less than 5, leave the digit in the rounding place as is. If it's greater than or equal to 5, add 1 to the digit in the rounding place, or round up. Drop all digits to the right of the rounding place, which is a little different. When we rounded whole numbers, everything then to the right went to 0. But in this case, you just drop everything because we're after a decimal. There's no point in rounding it out or writing out zeros anymore. When rounding a number, we either round up or round down. We already talked about that. Be careful when the digit in the rounding place is a 9. That's one thing I really do want to point out because that is kind of tricky. So here we have an example, round 5.198 to the nearest hundredth. So if you were to look at this hundredths place, that 8 rounds up that 9 to a 10. That means you bump it up even again to this 2 here. So 5.198 actually rounds to 5.20. So write the decimal to the rounding place, even if that means adding ending zeros. And this is the example where you would do that. So even though it's only 5.2, since you're rounding to the hundredths place, you go ahead and write 5.20. A repeating decimal, also called recurring decimal, is a decimal that has repeating digits or a repeating pattern of digits. A bar above a digit or group of digits indicates the digits are repeating. So in this example, we have 0.3 with a bar means 0.33333, which is actually 1/3. Negative 3.54 means negative 3.545454. Notice the bar is over both digits here. When rounding dollar amounts, remember that rounding the nearest cent is rounding to the nearest hundredths place. And this is important because I have seen people mess this up in other semesters. If it ever says round to the nearest cent, you need to have 2 decimal places after that decimal point. So 1/100th of a dollar position. For example, rounding the nearest cent, if you have 5.482 is actually 5.48. Rounding to a decimal place is different from rounding to a whole number place in the following way. When rounding to a decimal place, we drop all digits after the rounding place. When rounding a whole number, we change all digits after the rounding place to zeros up to the decimal point. So that's what I already mentioned that as well. So let's go down. We're on page, for anyone following along, page 11 on your turn. So let's look here. We have part A. We have negative 206.075, and we're rounding to the nearest tenth. That's this place. So we look to the right and we see that's a 5. So that means we round it up. So when we round up, we get negative, let's write that over here, sorry. Negative 206.08. Let's look at part B. We have 14.03883. And we want to round to the nearest thousandth. 1, 2, 3. That's our thousandths place. Okay. So that means we look to the digit to the right. It's less than 5, so this stays the same. So this would give us 14.038. And again, notice I drop everything after that. I don't write any zeros. The reason that's important is because when you're reporting numbers, I know this is not necessarily something you guys are going to deal with, but in the world of mathematics, statistics, physics, any of these things that use precise numbers, you're letting them know this is how significant this result is. It's rounded to this point. So I can't say anything about these digits that happen after it. And it's important to know that. All right, let's look at the next one. So here we have 0.39 with a bar over it. Remember, and we're rounding to the nearest hundredth. Remember that bar means it's repeating. So this is the same, well, this is approximate. I'm not gonna say equals. 0.39, 39, 39, 39, dot, dot, dot. And it says to round to the nearest hundredth. The nearest hundredth is right here. So if you didn't remember what that bar meant, you wouldn't know what came after it. So it's really important to understand that bar. So what we do is we look to the digits to the right. The digit to the right is 3. Do I care what this digit or anything over here is? Do I care? No, exactly. I don't care because I only care about that digit to the right of what I'm rounding. So now if I were to round it to the hundredths place, I would get 0.39. All right, let's do one more. We have D. $1.48 or 0.048. So if I need to round to the nearest cent, that's the hundredths place like we just talked about. So I'm gonna look to the digit to the right, it's an 8, so I know I need to add 1. So that gives us $1.05. Oh, if only money always rounded up. All right, any questions about rounding to decimals? If you're having a hard time remembering which decimal place you're looking at, make sure to go back to that chart. It goes tenths, hundredths, thousandths, 10,000ths, all that. So make sure you follow along with that. All right, let's go down. That was 5.1. That's awesome. We're starting to catch up. So let's go down a little bit. So here's our practice problems for 5.1. We have number 11, 15, 19, 23, 29, 31, 35, 41, 45, 47, 49, 55, 59, 63, and 67. I know it seems like a lot, but a lot of them are these easy rounding, just going from standard form to written form. So don't stress too much about seeing a lot of problems there. They're pretty quick. Okay, and again, those are just practice problems. So if you are really comfortable with this information, go straight to the quiz if you don't think you need it. So next, we're going to talk about how to add or subtract decimals. Again, I think you guys are going to find this a little easier than working with fractions. So adding or subtracting decimals is like adding or subtracting like fractions. But instead of adding or subtracting fractions with common denominators, we're adding or subtracting digits with common place values. So just like we did when we added whole numbers, you're going to line your numbers up vertically. The one thing you need to line up is your decimal point right here. Okay? So line up the decimal points and the value and place values vertically, add or subtract the digits, place the final decimal point so that it lines up vertically with the decimal points above it. So like what they mean by that is make sure your decimal point, your answer lines up with the other numbers in the problem. When adding, regrouping, or carrying is sometimes necessary. When subtracting, regrouping, or borrowing is sometimes necessary. Use zeros as fillers or placeholders so that all decimals have the same number of place values. This is especially helpful when regrouping, borrowing is necessary. Be sure to review the rules for adding or subtracting signed numbers. Remember, when adding two numbers with the same sign, you add their numbers and just keep the sign. If they're both negative, just add the numbers and then keep your negative sign. If they're both positive, just add them. When adding or subtracting numbers with different signs, subtract the smaller absolute value from the larger and then keep the sign of the number with the larger absolute value. When subtracting a signed number, add its opposite. Remember, switch everything to addition problems and then follow those rules. All right, so let's go to, we're on page 17 on your turn. All right, let me just write this down real quick. We have 16.93 plus 25.89. All right, so we're just gonna line them up vertically. And remember, you gotta make sure your decimal point is lined up. And then the place value. So we just go like this. 12, carry the 1, 9 plus 8 is 17, 18, carry the 1. Here we have 7 plus 5 is 12, carry the 1. And we end up with 4, so 42.82. Who here likes this better than adding fractions? I figure. All right, so what we're gonna do though, we're gonna keep going through a couple. I wanna go through the different types of examples. I just wanna make sure it's really clear. And like I said before, I'm not gonna be complaining if anybody wants to check this on your calculator. I know it's easier on your calculator, but I do wanna make sure you guys know how to line up your numbers. So here we have 14, and this one's a good one because it's got different, let me see if I can move this over here. Yep, all right, so we're gonna do it like this, and I'm just gonna line it up as I write it. So now I have an 8 here, with nothing after it. That means it's the same thing as 8.0, right? So we need to line up that decimal point and then make sure our value places are lined up, 1, 5. And I like to write a 0 there. In this case, I do because it helps me keep track of make sure I've lined up everything. So here we have 5. 1 plus 6 is 7. We haven't carried anything. 4 plus 8 is 12. Carry the 1, 2, and 2. Super easy. Now let's make sure we look at different signs. So in this one we have, see if I can carry it over here. Yep, there we go. What you guys can't see is I have like 2 monitors going. And so sometimes if I try to move the document over to show everything at once, it disappears on the other monitor. So I just want to make sure I'm not losing it for you guys. All right, so here we have A is 394 minus, oops, excuse me, I forgot the 0.77 minus 102. So didn't it say to add the opposite? So we would add the negative. So let's go ahead and switch this to an addition problem. 394.77 plus negative 102, right? So remember, in this case, we subtract the smaller absolute value from the bigger number, right? Does everybody remember that? Kinda, sorta? So what we would say is we would say 394.77, oops, gosh, minus 102. And since there's no decimal places, we know that's the same thing as 0.00. And so that we get 7.292. Now, this is negative and this is positive. That means we keep the sign of the bigger absolute value. If you don't remember this, this is what we just mentioned up in the important notes. Oops, right up here. So if you kind of forgot this, make sure to review this, okay? And if you have a hard time with it, check it in your calculator. All right. Okay. So now we know that the answer is going to be positive because our bigger number, our bigger absolute value is positive. So this equals 292.77. Okay? And really, we ended up just doing this problem anyway with subtraction. If you want to just do the subtraction without switching to addition and you're comfortable with that, that's fine too. The problem is going to be when you start ending up with like more negative numbers. All right. Okay, so let's look at part B. We have 63.99 minus 8.545. Gosh, you guys must be appalled at my handwriting. Okay. So if we were to look at this as an addition problem, remember what they said, 63.99 plus a negative 8.545. But then you're just going to end up subtracting it anyway. It's an awfully odd thing, but that's all right. 63.99. Again, the reason you want to switch it to addition too is once you start getting into subtracting where, like, let's say that this number was bigger than this number, that's something you can't just do a regular subtraction on. And that's why they have it, you switch it to an addition problem. 8.545. We're going to put a 0 there. So this is 10, that makes that 8. So we have 10 minus 5 is 5. 8 minus 4 is 4. 9 minus 4 is 4. Line up that decimal. We borrow, we get 5, 5. So we have 55. Now, the bigger number is positive, right? The smaller number is negative. So that means our answer is positive. How many of you guys are ignoring me and thinking I'm just going to do this on my calculator? You don't have to admit to it. I'm just kidding. All right, let's go down and do now a problem where we have positive and negative. Okay. All right, so we are on part A where we have negative 8.9 plus negative 11.27. And I want to point out, this is where it would have gotten complicated if let's say that this was positive and this was just a subtraction problem. So that's another reason. All right, So what's the rule when we're adding numbers that are both negative? What did we just say? You add them as if they're both positive and just keep the sign. So in this case, we can just say 8.9 plus 11.27. We have 7, 11, oops. 11 carry the 1, 10 carry the 1, 2. So this is going to equal, now they're both negative, so the answer is going to be negative 20.17. Okay? And let's do this last one. We have part B is negative 3.2 plus 19.5. Now in this one, again, we take the bigger absolute value, which is 19.5, and we subtract the smaller absolute value, which is 3.2, and we say 5 minus 2 is 3. Line up your decimal point. 9 minus 3 is 6, and 1. Now, this number is bigger and it's positive. That means our answer is positive. Now, if this number was negative and this was positive, that means that the answer would be negative. So remember, you go to whichever absolute value is bigger, you take that sign, that's going to be the sign of your answer. All right. All right, we're down on section B. So now we're going to estimate the answer when adding or subtracting decimals. So when adding or subtracting decimals, we can quickly check whether the answer is reasonable. Remember, I did that earlier with that perimeter problem of a rectangle. I'm telling you guys, I know that not everyone listens to me, but please, even if you outside of this class and anything you do, if the answer doesn't make sense, take another look at it, okay? When adding or subtracting decimals, we can quickly check whether the answer is reasonable by estimating. There are many methods for estimating. Here are 2 methods for estimating the sum. Now, we already talked about these, so this is just review, but now we're doing it with decimals. So front-end estimating is round each number to its leftmost place value. So in this example, we have 35.07 and 4.61. The leftmost place value for the top one is 3. When we round it up, we get 40, right? Because that 5 rounds it up to a 4. Here we have 4.61. When we round up the 4 based on that 6, we get 5. So we know the answer should be about 45. Common place value estimating is where you line them up and you take whichever one they have that's in common all the way to the left. So this number on the bottom does not have a tens place. It does have a ones place. So that's the leftmost common place. So we round here. So 35, you go to that 0, it rounds it down to a 35. 4 still rounds to a 5 because that was where we rounded before that. 6 rounds it up to a 5. So 35 plus 5 is going to give us 40. The answer is 39.68. So it's reasonably close to both, but notice it's a lot closer to that 40 over here because we rounded a little more precisely. So the process is for front-end estimating, round each number to its leftmost place value, add or subtract as indicated, compare the answer to the exact answer. Common place value estimating, round all numbers to the first common leftmost place value, add or subtract as indicated. Compare the answer again. Important notes, these estimating methods can be used as either a quick estimate without doing exact calculations or as a check for how reasonable an exact calculation is. Remember, I mentioned this example in that first section when we did this back in either module 1 or module 2, I think it was module 2. And I said, let's look, like when you're at the store and you see $3.99 for one item and then $4.95 for another item. When I'm telling my kids, I'm like, oh yeah, that's like $4 and $6, it's about $10. Now, my daughter always goes, no, it's $3.99. She's always very particular, but you know what I mean. You're estimating, oh, I have about $15 in my purse, and this is going to be $10 between the two, about. So that's what they mean by a quick estimate. Estimating can be done with positive and or negative numbers. When a decimal starts with a leading 0, that leading 0 is not the left. Thanks, Joy. That leading 0 is not its leftmost place value. For example, the leftmost place value of 0.31 is the 10th place. This 0 does not count as a value place. That is just saying that there's no whole number part there. When checking exact answers, a good general rule of thumb is to use front-end estimating first, Then if the result is very different from the exact answer, do another check with commonplace value estimating. If the exact answer is close to either estimate, the answer is reasonable. Note that estimating sometimes gives a very rough approximation, so consider the estimate and exact answer as close unless they differ greatly. And again, there's no like, it has to be within 1 or it has to be within 2. You do need to use a little like common sense here if you think it's reasonably close or not. All right, let's go down to your turn on page 21. Perform the indicated operation, then check whether the exact answer is reasonable by using front-end estimating and commonplace value estimating. So let's go, I'm gonna write this problem down. A, we have 16.409 plus 8.93. Okay, so first we're I'm gonna write these down just so we don't lose track. Exact, front, and common. Okay, so let's do the exact first. So we have 16.409. And remember, we need to line up our decimals, 930. So we add them up. We have 9, 3, 13, carry the 1, 15, carry the 1. So we have 25. So that's our exact answer. So let's go ahead and do our front and see what we get. So when we front end estimate, remember, we just go to the first number. So front end estimating is going to round this up to 20 and is going to round this up to 9, right? We looked at that front number right here. That 9 rounds that up to a 9, and that 6 rounds that up to a 2. So we get 29. That's our front end estimate. That's pretty close to 25, but let's go ahead and line up our numbers again. We have 16.409 and 8.930. Do they both have a tens place? No. Do they both have a ones place? Yes. So that's where we're gonna round for, this is for commonplace. Okay, so we're gonna leave that 1 there, that 6, that 4 leaves it down to a 6, right? That rounds it down. If it was 5 or higher, we would round up. We're gonna round that 1 to the same place, right? That 9 rounds it up to a 9. So when we add that, we get 15, carry the 1, 25. So that's our commonplace, that's our front, and that's our exact. You notice it's reasonably close to to both of them, but it's very close to that commonplace. Does anybody kind of vaguely remember this from way back when? Yes, glad somebody does. Thanks, Sarah. Sylvia, I'm sorry. Okay, so we have 13.5 minus negative 57.6. What happens when we subtract a negative? Does anybody remember? Can't see. Thank you, Joy. I'm sorry. Thank you. Anybody remember what happens when we subtract negative? That's the same thing as saying we're adding, right? So we can say 13.5 plus 57.6. So let's do our exact. So we have 13.5 plus 57.6. Oh, that's nice. They have the same decimals. So we have 1, carry the 1, line up our decimal. 11, carry the 1, that's going to give us 7. So we have 71.1. That's our exact. Let's look at front end estimating. So remember, we go to that front one. So here we have a 1. That 3 rounds it down. So we have 10 plus. We go to the front end. We look to the number to the right. That 7 rounds it up to a 6. So we end up with 70. Ooh, that's pretty close, huh? Let's do commonplace. Now I'm gonna go over here because I'll write it up here. So we have 13.5 and 57, oops, that was not right, 57.6. They both have a tens place, so we're gonna go ahead and round them there. Ironically, we already just did that, so they're the same, right? That 3 rounds that 1 down to a 10, and that 7 rounds this up to a 60. So in this case, the front end and the commonplace value estimating ended up being the same because they are both the same spot right there in the front, that tens place. And they're both very close, right? So that number is very reasonable. Any questions about that one? All right, I'm gonna go ahead. Let's do this. Time for one more example and we can finish up this section. All right, so let's go ahead and do this one. We had 83.01, oops, minus 9.9. All right, so let's do our exact. So we have 83.01 minus 9.90. So 1 minus 0 is 1. We're going to borrow. 10 minus 9 is 1. Line up our decimal. We're going to borrow again. 12 minus 9 is 3. 73 is our exact. So let's look at front end. So again, we start here. We look to the right. That 3 rounds it down to 80. We're going to look here. We're going to look to the right. That rounds us up to 10, minus 10. So our front end gives us 70. Well, that's pretty close, right? Let's look at our commonplace. So common, again, we have, let's line them up so we can see what we've got. 83. Oh gosh, guys, I'm sorry. Okay. Let me do the front end again real quick. Sorry about that. You guys could all see the exact, right? You guys saw most of that. So let's go back to the front end. All right, so front end, we look at the 8. That 3 rounds it down to 80. That 9 gets rounded up to 10. So that gives us 70. That front end is 70. So 73 is very close to 70. Let's do common. Okay, so 83.01 and 9.9. They do not both have a tens place, but they both have a ones place. So that's where we're going to round. So that 0 rounds that to 83, and that 9 rounds up to 10, because that 9 makes that a 10. When we subtract these, we get 73, which is very close. All 3 are close. That tells us that this answer is probably, it's reasonable. All right. Any questions about how to do that? All right. Well, that might be a miracle. We actually just got through the material for module 11 as well. So I'm going to go ahead and give you guys the practice problem for that. You guys still don't have to do the module 11 quiz this weekend. It's not going to be due until next Wednesday. But I do recommend, if you're on schedule, to go ahead and work on it if you have time this weekend, because the more you can do now, the less you have to deal with later. So the practice problems for 5.2 are 7, 9, 13, 15, 17, 21, 41, and 43. So again, we've finished all the material for module 11. So that's great. That gives us a little bit of wiggle room to cover some more questions next week if you guys have any, okay? So if you guys have any questions, let me know. You for sure need to finish your module 10 quiz this weekend. Start working on module 11. And if you have any questions or you need any help or you want to schedule like a meeting with me, you need to let me know, okay? I'm more than willing to help. Just reach out to me, okay? And I will talk to you guys next week. So have a good weekend.